I think even the video played seemed like it was delayed. I am having weird delay issues, so I'm living in the past, but you all can hear me, so that's
Yep.
good. And I'm trying to do these hand movements to see like myself do it, and it's weird watching yourself 5 seconds later. So anyway, that's all aside. I'm not doing a whole lot of talking today, thankfully. But I do have Zach and Peter here for Tetrate. So I wanted to welcome them. Zach, go ahead and tell me a little about yourself and what you do.
Yeah. Hey, cool. Thanks everybody for spending some time. So I'm one of the founding engineers here at Tetrate. Before that, I was actually one of the original engineers on Istio back at Google. These days at Tetrate, I help lead our product organization. One of the other kind of big hats that I wear is actually working very closely with NIST, the National Institute of Standards and Technology, helping write some of the standards for microservice security in cloud. And so that's another kind of interesting hat that factors into a lot of the stuff that we're actually going to talk about today, because Service Mesh obviously has a huge overlap with security. And Peter, you want to introduce yourself real quick?
Yeah, absolutely. I'm just here to support Zach with moving, I guess, cursor on the screen. I'm implementation engineer at Tetrate, working with multiple enterprise customers on implementing Service Mesh and working on some projects that include AWS. And basically, yeah, just hands-on on all cool technology.
Yeah. And Peter actually did all the legwork for the demo today, so I couldn't not have him along to actually do it, because he did the hard work to get it prepped.
So give me the elevator pitch for like what is Tetrate, what service are you providing and problems are you solving?
Yeah. So look, the world today as we're building modern applications is crazy, right? We're in multi-sites, multiple clouds, we're deployed all over the place, right? And it becomes very hard to have consistency anywhere in terms of how applications communicate, your security posture, how we run production, right? And so really the service mesh we view as a really, really key infrastructure layer for providing consistency. And at Tetrate, we're really all about bringing that technology into enterprise, right? So, some of the original members of the company here, Varun, our CEO, for example, myself, Lizan, and others, were some of the earliest engineers on Istio at Google there. And that's where we kind of, first inside of Google internally building out the service mesh implementation there, we were dealing with a lot of these problems of how do we handle monolithic API gateways in the world of microservices and cost accounting and caching. How do we deal with the connectivity reliability? How do you get consistent metrics, right? We had that problem internally inside of Google. We built some pretty compelling solutions there. We built what we thought was a pretty nice architecture for achieving that. And then eventually went and decided, hey, we're going to start the Istio project to open source that, right? And so that was back in 2016. And we jump forward to today. Tetrate has been around for about 3.5 years, since 2018. And from the beginning, we set out to build kind of one thing, which was today what we call Tetrate Service Bridge, which is basically a management layer over top of Istio. And the goal is basically solve the gaps that an enterprise has. And there's a couple different ones, but there's really one that we're going to hone in on today. So overall, a lot of the gaps include things like governance, management, audit, right? I want to use a service mesh to implement zero trust, for example, at runtime. That's more than just encryption in transit. We also need things like we need visibility there. We need, quite policy enforcement there. And we need to do it across multiple clusters. So we can't have just one cluster that's a toy. Nobody has like one Kubernetes and that's like their entire production, right? Or if they do, they're probably out a lot.
If they have one, they may not need Tetrate.
Exactly. If they have one, they probably don't need us yet. And the reality of a lot of the customers that we deal with is that they're spread all over the place, right? They have an on-prem legacy footprint. A lot of them even have some mainframes back there as well, right? And they're moving into cloud. And probably because they have an acquisition or two, it's not just one cloud, right? And so they need to figure out how to rationalize across this. And then even in one cloud, just AWS, for example, they need to be able to rationalize application connectivity and security posture across EKS, ECS, EC2, all the Lambda, right? All the different ways that they're deploying applications. And so for us, this is the key thing, right? So we see the service mesh as a really, really powerful tool for runtime policy, for implementing zero trust and all these other pieces. And we come in as a layer on top of the open source project to really bring that to enterprise, bring the identity, bring multi-tenancy, bring robust lifecycle management, and bring that multi-cluster management. And today, that's really what we're going to be showing off. For me, that's particularly exciting. So the area of Istio that I worked on was the networking APIs. And so back in late 2016 into early 2017, we had this very clear vision of being able to use Istio to do multi-cluster networking, multi-site networking. Even though we were kind of at the time only doing it within one cluster. And even through that time, I personally had built demos, for example, doing multi-cluster failover and things like that. Today it's going to be really cool to show y'all exactly some of those pieces that have been kind of quite a while in the making, kind of culminating, and we're going to show you some pretty cool reliability, resiliency pieces. We'll talk through the demo setup in a second, but I'm excited.
And so me explaining this back to make sure that I catch that, a lot of the benefits you're describing, at least initially, are around security and around how to make sure that your applications are secure, and then broadening that into multiple connections between clusters, but not just multi-cluster, but actually things outside of Kubernetes. How are we getting
multi-sites? Exactly.
Yeah, and that's where other things, like if we're looking at maybe the CNI, like my network layer could kind of give me connectivity, but not necessarily when it's an EC2 instance and it's a Lambda and it's something else.
Yeah. Well, and even one step beyond that, great that you have the connectivity. What about your security policy?
Right.
So is it based on that IP address? That doesn't work. Like the pod changes all the time, right? And so we need to really elevate identity out of the network, so that then we can have policy that's not bound to the network either, right? And that's one of the other key things. The service mesh gives us that identity, and TSV lets us do it across cluster. And
moving that closer to the application is always a good sell, because I could do firewall rules, right? But that's IP based. That's like, who likes dealing with firewall rules and IP tables? Like,
not even that. It's not practically feasible anymore. Right. So one of the key pain points, I was literally talking with a customer last week, a prospect last week, and they were talking about, they're super excited because they're going into AWS. They're, the application developers are excited because they've been on-prem doing old stuff for forever, and they finally get to go do new things. And one of the big pain points is that they have a VPN, they have a DMZ that sits between AWS and on-prem, and they have firewalls in that DMZ, and it takes 3 weeks to open up a hole in the firewall. Right. And so, it's not just that it's an alternative to these existing solutions. It's really that those existing solutions don't scale, or they were not built for the current environment that we're in. Right. And so they don't really work effectively to provide fine-grained security, right? To provide, application level assurances that we're secure. Right. And, again, we just don't have that notion of application identity. It's bound to the network, and that just doesn't work anymore. And so one, to take a step back and maybe I think a lot of people are probably familiar with the service mesh, but I do want to introduce it just a touch. And I'm going to borrow from Kelsey Hightower. We were talking, and he gave a beautiful analogy for the service mesh that I thought was really, really great, right? And he described it as a home security system, right? And this is maybe the model to think about it. So how does the service mesh work? Well, how does your home security system work? When we come in and you get one installed, the first thing they do is they look around everywhere, right? They identify all the entry points, all the places the stuff can get into the house, right? Windows, doors, whatever it is. And then next step is we go and we put control equipment on each of those, right? Your windows are going to get the opening sensor, right? That goes off. Your doors are going to get the same, right? In a service mesh, that's just like the Envoy proxy, that sidecar that we're deploying beside every application, right? Now, all those sensors by themselves don't do anything, right? They need to feed into a central system that can manage them, that can watch them, that can go and alert HQ when it goes off, right? And that is effectively our control plane, that Istio piece, right? And then, of course, if you actually go and buy a home security system, there's probably some management piece over top that the company sells you as well. So you can use your app to go look at the system. You don't have to be right at the keypad and all. And that's in a lot of ways kind of like TSP, right? But I really enjoy that home security analogy because it's not, sidecars are very abstract, right? But I love that idea of, look, we're going to go find every place that we can go in and we're going to lock it down. We're going to put that proxy, we're going to put that sensor there so that we can lock it down.
Yeah, that makes a lot of sense. And, home security systems, if it's just noise, right? Like it would work when I'm home, but it wouldn't work when I'm not home. And so having that control plane, managed for me by someone else that does have that, follow the sun rotation sort of thing, is necessary.
Yep.
So let's dive into it. Let's see. I know Zach, you had a couple things. Let's pull.
Yeah. So let me walk through our demo setup real quick. So can we see this?
I can.
Yeah. There we go.
Switch this over.
Good. All right. So for folks that have seen meshy things before, you have certainly seen book info. The app mesh examples use it. Istio uses it. Everybody uses it. And so why break with tradition? We're gonna use that as well as our simple application. And what we're going to be doing is distributing it across a couple different pieces of infrastructure. So let's focus on the bottom here first. We have EKS Anywhere running. It happens to be running in vSphere on Equinix, on the Equinix Metal cloud there. We have OpenShift running. We're running it on EC2, and we also actually even have some EC2 VMs as well, just raw VMs, not enrolled in Kubernetes at all. And so that's where our application is running. And I didn't bother to label the book info services. So inside of that book info services is this, right? So we're assuming that we have an active application that we can replicate across. We don't necessarily need to replicate all the services, but we did just for simplicity. And user traffic is going to come in to this piece that's not part of the normal book info, that tier 1 gateway. And so we have that deployed in a separate cluster out by itself. And what it's going to do is really be the entry point for users that are accessing it. And it is the point that will then distribute that traffic across clusters. And I'll point out, we're running that in EKS there, but that's distributing traffic over into Equinix Cloud, right, as well as onto EC2. And then what we're going to do is we're going to emulate one of the services failing, not the entire application, just one of the services. And we're going to show, for example, an automatic failover there where we don't need to take intervention to make that happen. Then we're actually going to scale out and enroll a new cluster there and distribute traffic across all of it. And of course, just to kind of finalize the picture here, those services communicate in and amongst themselves. And some of that traffic includes, for example, calling this rating service on the VM. And that's facilitated by this as well. It doesn't go through that tier 1. And then finally, just for completeness here, we're going to be making configuration changes with a tctl tctl UI, CLI, as well as looking at a UI that is Service Bridge's backend and UI server. We happen to be running it in the same cluster that we're running our tier 1 gateways. We don't have to. We just did that for simplicity. And at the end of the day, what that's going to do is push configuration that we author across these different clusters that are connected. It's going to go there to a local control plane that we have. And at the end of the day, it's going to be Istio configuration that gets popped out, that goes and programs Envoy, these ingress gateways, as well as the sidecar envoys that are deployed beside the actual services themselves. So that's going to be what our setup is. And we'll walk through that failover, plus then adding the extra cluster in and seeing traffic and policy go there live.
Sounds cool. I'm excited. Let's see.
Yeah. And with that, we'll go over to Peter, who's actually gonna kind of be steering, and I'll be providing some color commentary here. So as we come in, first, just to kind of set the stage, and we're a little zoomed in here, so the UI normally is we're zoomed in to be able to see everything. So it's a little cramped. We apologize. And just to start with, like I said, we have we have another cluster that we're going to show you in a second here as well. That's why we have 4 here in our list. And so right off the bat, we can immediately see where these are, what's coming from, what version of things are deployed in each of them, right? But Peter, let's go ahead and look at the global topology. So first, we can come and get a sense of all the services that exist in the system. And this is everywhere that they're deployed, right? services are only in one cluster, services that are in all the clusters. We're going to see them. We can get a snapshot view of the health. Critically, this view, by the way, is scoped. We skipped the login. It ties into like OIDC, and you're going to see your services. But much cooler topology. You know, how do you describe what an application looks like? Well, I just showed you a box and line diagram, right? That's how we talk about architecture diagrams. This is kind of the way that we think about the world. You know, TSV draws that based on the observed traffic that we see. And so if we zoom in to maybe the OpenShift cluster there, right, we can go in. Scrolling is a little funny in this version where we deployed an alpha release here. So we're living extra risky. We didn't even deploy a full-on customer release. So more fun that way. Because we want to be able to show exactly what we're doing live. We want to be able to show the fun stuff. You know, and so here we can see this OpenShift cluster, and we can see we have a book info namespace, and we have a bunch of services deployed in that namespace. We'll dig into that more, but this is the standard book info application. And we can see that there's maybe some external communication that's happening. If we go over to the other cluster, it's identically the same, right? So we have the same application deployed. You know, we're in this case, we're simplifying things and assuming it's an active-active setup. You know, we can get into the weeds. We can do this failover per service and similar, right? And we'll show you doing it per service, not failing over the entire cluster. And then, of course, we have our tier 1 gateway down there at the bottom as well. And so, like I said, this is really the entry point for customer traffic, for user traffic, for external traffic. And what it lets us do is distribute that across any of the sites, any of the clouds, any of the clusters that we have.
And at that point, that's your DNS points here.
Exactly. Exactly.
And then the sidecar, the gateway is actually telling it, okay, this is, you can have weighted, I'm assuming weighted entry for like, yeah. I want 50% over here, and then the rest of it failover or spillover, whatever goes over here.
100%. And so we'll actually show that when we bring in the new cluster, we'll show that. So in fact, let's go maybe look at that tier 1 configuration right now. So if we go over to Workspaces, this is a cool thing that we've added here. So, one of the big challenges is how do I start to manage a bunch of different Kubernetes clusters that, as they get scaled out and things get deployed into them. We have this notion of a workspace. It maps to a set of namespaces in Kubernetes, and that's what you would associate with a team within your organization, for example. And within that workspace, there's going to be, the services that are present, as well as a whole bunch of different configuration, including the clusters behind it, and what we would call our tier 1 gateway config. And that's exactly where we do that percentage-based, how much goes to which cluster. And so if we go and look at the gateway group here, we can look at the tier 1 gateway, and we can see in the configuration that we have an 80-20 split.
Actually, it's 50-50 right now.
Yeah, I saw the port 80 there and misread. But yeah, so 50-50 split across the two clusters, right?
And we can be granular and do it by service. So there's 2 services right now, and each of them getting different configurations. So it's complete flexibility.
Yep. And then one thing I want to touch on real quick too before we dig in further, right? One of the big pain points when we talk about the service mesh with people, and I'm partly guilty here because I worked on I helped author some of the configuration, is like it's really hard to write service mesh, Istio config in particular, not just service mesh in general, but Istio in particular has, it can be challenging to learn the configuration, it can be challenging to author it. We're showing you some YAML that looks a whole lot like Istio config. One of the really big things that we've done to try and help simplify is actually pull this out into Open API specs. So Peter, if you don't mind popping open real quick the Open API spec that configures some of these. We may actually just have to show the text file probably.
Okay.
And that, all we've done basically is taken an existing Open API spec and we add one annotation that tells TSV the service to send it to. And we push that into TSV and we get all the routing here. So this is, a full API, Open API spec that might have been generated, from our app itself. Nothing special here, nothing crazy, with the exception of one annotation. Sorry, it's a large file. Open API has a lot of stuff in it. But literally there is one change that we have made to it, which is that XTSB service annotation up at the top. And so as long as we have that annotation there, you can push us the configuration. We're going to do all the routing. And we do quite a bit more besides. So there's about 5 annotations that a developer might want to know that enable routing, canarying, rate limiting, auth-in, auth-see, right? So the kind of bread and butter things that an application developer wants to get done with the mesh are actually embedded right there. And so you don't have to learn all these different configurations. It's your Spider spec. And so for us, that's a key idea for making it easier to approach the mesh.
Is the workspace a Tetrate abstraction?
So the workspace is a Tetrate thing. So workspace is a Tetrate thing. So the name, the service mesh itself, Istio works at a namespace level, right? The problem that we have is we're trying to describe namespaces across clusters, right? And so it's great if you have a simple, like we have the exact same naming convention everywhere, then you can maybe make some simplifying assumptions. Unfortunately, that's not actually the case in reality, right? There's going to be like small changes, small heterogeneous pieces and stuff. So you need a little bit of smarts to be able to map things together. And so for us, Workspaces is that way. And so one of the things we're going to do in a second here is actually just bring in a totally new Kubernetes cluster. We're going to deploy with nothing in it. We'll deploy the application. That workspace, because of the way that we have it configured, is going to recognize that cluster joining TSV and exactly send all the correct configuration from the very get-go. So it creates a very highly dynamic system.
We'll get into that later. Where does that mapping happen? Because it's not in the Istio config here, so that has to be.
So that happens in Service Bridge itself. So TSV manages that mapping, and then it pushes configuration down to each of the individual Istio clusters. Or each of the individual clusters, rather, gets Istio configuration, I should say.
Okay.
Because they don't all get the same config. So right now, we're showing you a very simple case where we have the exact same application replicated across multiple clusters. But obviously in production, that's not going to be how your real system works, right? You're probably only going to have subsets replicated out in different places. And so, of course, you have to account for that in a real enterprise environment. We are just taking the simplest one, which is identically the same. Great. And so we have this. We can dig in as well. So having a global view is great, but if we go look at like individual services, there's also a lot of great information there. So Peter, why don't we go dig into, for example, the rating service real quick, or the reviews. So there's some high level metrics, but let's actually just go over to the service details page.
Okay.
Yep, and so we see, hey, there's multiple versions here in the list, but we can click through here and get a very scoped in view, right? And so as an application developer that maybe owns just 3-4 services, I'm only going to have 3 or 4 in that list to be able to go look at. And of course, we can see that health globally. I'll point out, these are deployed across a bunch of different clusters that are running in a bunch of different compute providers, right? And we can still see a single global view for health here. Now, I want to break it down because a lot of times my failures are going to be per zone, per region, per provider, right? So of course I want to be able to drill in. And so you can drill in, the application versions themselves, as well as the physical sites that they're deployed, right? So we can look at, for example, V2 in EKSA, for example, right? And drill down all the way. And of course, even things like tracing gets embedded in here. We have in addition, we have things like the Envoy metrics as well are embedded there. So this really becomes kind of a one-stop shop for being able to handle. But let's get into the actual. Let's see some action. One other thing I want to show you. So there are Envoy metrics here as well. So one of the unfortunate leaky abstractions of the service mesh is that you do know that there's an Envoy there sometimes because it causes problems. And so one of the key things is being able to understand the health of that Envoy too. That's embedded there. And then finally, let's look at the dependency view real quick. And that is, again, a scoped in view of that global topology that just shows me my service, the immediate things it calls, and the immediate things that call it, right? So a very, very local view to be able to get that time to recovery down, right? Be able to understand kind of in a snapshot, what is it that's happening for this particular service. All right, and so with that, though, let's go ahead and see what happens when we have a failure. And so I mentioned what we're going to emulate here is in EKSA. We're going to say, this is deployed in a data center. Let's suppose there's a networking failure or something similar that knocks out not even the entire cluster, but really just one service. So to emulate that really easily, we're just going to scale it down to 0. And so we're going to say, look, details doesn't exist in this cluster anymore. It's been blown away. We see that it's terminating. It'll shut down in just a second here. And what's going to happen is we're not actually going to have any user perceived errors here. And so we don't have there's a curl loop running in the background somewhere that's printing out 200s very happily. And if we go look at the metrics, it takes just a little bit of time to update. But what we'll see once we actually finish terminating eventually, there we go, is that we actually automatically fail over without any intervention, right? And this is because we know what services reside in which clusters. We know where they are. We can see that in EKSA, details is sad, it's unhappy. There's 0 instances of it running. And if we go look at our topology, what we should see is a new connection, and we need to look. We have to be careful for time here because it takes a little bit of time for the graph to update. But what we'll see in just a second is that actually a new edge will appear in our graph, and that edge is going to go across clusters for us because what we're doing is actually failing over just the traffic for detail service from the spot where it's unhealthy in EKSA into OpenShift. Maybe do a hard refresh on the UI there for me.
Now, something I found interesting that you mentioned at the very beginning of this conversation when we were talking about, what Tetrate's doing, almost everything you mentioned was about security. And here, everything you're demoing is about resiliency. And I'm curious, where do I see in the UI, is there anything here for me to actually validate, I have mutual TLS, or how do I configure, this service can't talk to me? We can definitely go into, I want to see this piece with that edge. I think that's it right there. That just popped up, but I'm curious to know where are those security boundaries displayed, and how do I see who's allowed to talk to me?
Yeah, that's an excellent question. So, of course, in the topology, we have things like the lock, the ubiquitous MTLS lock. Kiali does the same. I think AppMesh visualizations do the same. The help you visualize encryption in transit there, right? And so you can see that in our diagram as well. So that's one of the high level ways to see that. For us, though, one of the big things is that most organizations that are adopting a mesh don't want anybody to turn off MTLS, right? That's kind of an anti-pattern, because the whole idea is that we offload the mesh once, we do it, it's good. And so we actually have a hierarchical permission model here with hierarchical configuration. And so we actually have a setting up at the top that says MTLS is mandated everywhere in TSP. And that's actually just being enforced transparently. And we handle, we'll plug in, for example, the ACM as a certificate provider for each of the Leaf clusters so that we can have that standard rooted trust. And this is actually an FAQ I get all the time when we come in to start to talk with folks that are adopting a mesh. They go, hey, how do I handle mesh trust? Where do I, do I have a separate PKI for it? Do I make it part, make it part of your existing PKI, please? We've gone and built out, and in the community, there are pieces there to be able to integrate with providers like Venafi or AppUX or AWS ACM, right? To be able to fit with your existing certificate providers. And so because we have a common
switching certificate providers is a big blocker for a lot lot of people. It's no, actually, exactly. That's not going to happen.
Exactly. Nor should it, right? You shouldn't need to for this stuff. How does it work with Azure? Does this work with Azure? It does. So I actually cut the AKS cluster from this demo so that we could simplify it a little bit. But the original cut of this did in fact have AKS off to the side as well. So yeah, any of the clouds, any of the we can run on anybody that is providing Kubernetes, and even beyond Kubernetes VMs and similar as well.
So just a little bit more to explain what happened here. So before we had tier 1 cluster sending to two different EKS-A and OpenShift. Now, because details is down in EKS-A, actually it finds all different detail services anywhere it knows about. And right now we have OpenShift where we saw it before, but also we have another cluster that we are not sending traffic, incoming traffic to. But we discovered that it also has detail service. So it's now calling whatever detail service is available outside of cluster where it's down. So it's why we see extra cluster here. So it's not actively accepting incoming traffic, but it's accepting failover traffic when it's not enough.
Yeah, can we zoom into that top cluster there actually, Peter? So that's exactly correct, right? So, previously this other cluster didn't appear in our diagram. So let me, the spoiler is we draw this diagram based on the observed traffic over the time range up in the top right there. So this is not a total view of all possible traffic in the system. This is a view of the observed traffic over a time range. And so because we weren't sending any user traffic from that tier 1 into this cluster previously, it didn't appear in our topology. Although TSP didn't know about it when we saw that cluster list, right? But there we see that just like we were able to fail over in OpenShift, like Peter said, we were able to fail over into this internal cluster that also hosted details. And of course, if I needed to or wanted to, I could disable that as well. You also asked about the access control there. And so we have a notion of security groups as well. So we looked at the gateway group, we have a traffic group. In the same notion, we have a security group. And that's exactly where you would control, if we go ahead and just make one real quick, this is where you can control who can talk to whom. And you can do that at a couple different levels of granularity, of course. So namespace to namespace, service to service, but also, these TSP constructs of workspace to workspace are allowable as well. And with that, we can go in and there's a variety of different settings that we can dig into there. Click onto authentication settings for me real quick, Peter. Yeah, and so, here, for example, so all that's required, for example, to mandate MTLS in an environment is hitting required and then hitting save, right? And that flips on MTLS everywhere.
That's already coming from the top level, right?
Yeah, exactly. So it's already applied here. So now what we want to go do is we have that other cluster running. So in our case here, EKSA, our service died. We saw the automatic failover. But in a real production environment, we're probably not provisioned in just OpenShift there to handle the entire load, right? We had a 50-50 split before and we failed over all the way over to one. Hopefully we're there. But the entire reason we're deployed on EKSA, technology like that, is to facilitate doing things like moving into EKS, right? And so one of the easy things that we can do, because we already have that cluster ready off to the side and it has book info deployed, we can just go ahead and update our tier 1 gateway to send traffic to it, right? So previously we had a 50-50 split. Here, great, we're doing a roughly 33-33, right? 30-35-35 split, right? So that's great. And if we go and look at the diagram, we'll see it takes a couple seconds to update again. But if we go and look at that, we'll see traffic start to flow from the tier 1 as well. But this is, and by the way, we also see the services discovered from that cluster as well. So that's nice. We have the immediate failover of traffic. We have the policy there and everything. But it's a little lame that we kind of cheated and already had a cluster running. And so one of the things we want to do as well after we see this pop up is just bring in a totally new cluster from scratch and show off that too. There's no, this is not a super long time consuming process. It doesn't take a bunch of work to deploy it. And so we'll actually go and bring in something live.
There we go.
Beautiful. And so now we see all 3 replicas of our system. If we went in and looked, it's drawn a little bit overlapped, but we have the same set of services that are deployed, a few less versions of the various services in the secondary cluster. All right, so does that make sense for folks? Let me pause. Are there questions, comments, concerns?
I didn't see a whole lot of new questions about this specifically, so I think we're
cool. Good.
I think we're going on good.
Good. All righty. And so now, okay, great. So we have the exact same services there. They have the same policy. They have traffic flowing to them just like before. By the way, one thing, Peter, let me point out real quick, our detail service is still unhealthy in EKSA. And so first off, that's being colored in the graph. Now we can start to see that node, that edge being unhealthy between those. And 2, we see that the failover is still happening into both of our clusters, right? So even though we went in, we added this new cluster, we started to send user traffic to it, that in no way interacted with the failover that automatically happened. Right, so we're still failed over, the user continuity is still there, right? They're still receiving traffic, even though we're unhealthy in EKSA. All the other services in EKSA are still serving as well. And here, we have the full thing.
Is in seeing this line connect between the graphs here, or between the clusters.
Mm-hmm.
That actually, I mean, it's a straight line here, right? Like it's just drawing a line between 2 points. But actually, that traffic's NAT gateway out. The clusters need to be connected together at some level.
This is actually happening. We're doing this over the internet. So yes, traditionally in a traditional kind of edge-based security infrastructure, you would have to do that. We'd have to set up a VPN. We'd have to have a NAT gateway to preserve our addresses, and all of that mess, right? And that's exactly the stuff that takes so long to update, that really kills a lot of the agility of moving to cloud for organizations, right? And so, as a matter of fact, we do have a VPN set up here. It's connecting Equinix into the VPCs in Amazon. So that is present. But actually, all the communication between the different clusters in Amazon is happening over the public internet. And the reason that that's safe for us to do is because it's all encrypted in transit with the mesh, and we carry that identity through end to end. So we can write a policy, and even though we're going out to the internet and back into our cluster to hit that other instance, we have the correct identity end to end. We can have the correct policy applied end to end there.
Because the identity is stored in Tetrate, so that every time the service is being refreshed.
Well, not even actually. The identity is stored in Istio. So Istio is the one that's handling the identity for us at runtime in the certificate that we use for MTLS. So that's a cert that we use to go and encrypt the traffic in transit. We also use that to carry the identity. That's spiffy. Right. And the key advantage, though, that we do is make sure that identity is consistent, and make sure that policy is consistent across the places that it needs to be present.
So my other question I was leading to was, can I see what my latency is from that? Now that I'm failing over to 2 different places, I should see a different latency to each one, since they're physically 100%. Different locations.
Yeah, so why don't we go look at that real quick, Peter? And there's a couple of different places that we can see that, by the way. So why don't you click on the node itself, the orange node. And y'all, sorry, it's small. Again, the graph, unfortunately, does not zoom in appropriately in this build. So I apologize. And so here you can see the response time for that particular edge go up. But if we go to the service details page for that entire service, then we can see that fine grain breakdown of metrics. So it's details that's broken. There we see that very clearly in the list. We see that in aggregate, it is actually healthy. It is serving. But if we scroll down just a little bit, we can, we go look at some of the specific clusters. We see it's actually even
not listed here anymore.
Yeah, it's not listed because, again, this is driven off of recent discovery. And so because it's not even present, it's been long enough that we've been talking through the demo that we killed the instance far enough ago that it dropped off, actually. So this is, again, a little bit of a bug we're trying to fix there to keep that around a little bit longer, even though you're only looking through a time window. If we opened up that time window to about an hour, we would see, certainly we would see the one in EKSA.
Cool.
And what we would see actually is if we go to the, we should see it.
And I was curious because that's always like one of the things where I'm like, oh, well, now some people are getting a slow delay, and why are they getting a slow delay? Because then I could even wait even more and say like, oh, well, with this failover, hey, I actually want you to prefer the low latency connection, but when that starts hitting capacity, let me go ahead and
keep it local. Exactly.
At least give someone a response. Yeah.
Exactly. And so that actually does happen here. So and that's happening under the hood in that automatic failover. So in that automatic failover, we're taking advantage of Envoy's locality prioritized routing to do exactly what you just described, Justin.
Cool.
And so if we went to the product page dependencies, I think we would see the detail service SAD. It should be here. I think it's because I mentioned before we started the call that we're living it risky, and we deployed an edge version, an alpha version, and I think we had a little regression there. But always fun. That's the perk of doing it live.
And I didn't want to detract too much from actually going to a fresh cluster.
No, that's a huge use case, right? So of course you can see that there in the topology. That is normally there in the individual service details page, but so it goes. It wouldn't be a demo if something didn't go wrong. Great. Okay, so last thing I want us to do is go ahead and enroll that last cluster. And so no, TSB that we're showing off here is not open source. So we are using, though, as the actual engine to do all of this stuff, a couple key open source projects. So of course, Istio and therefore Envoy are the primary pieces that are doing the runtime here, right? And those are just straight open source Istio. So it's not, we don't have special builds, we don't have special things that we've added. We're using just normal upstream stock Istio here, and all that we're doing is programming it locally in the cluster. There's a couple other components. So obviously Envoy is part of Istio, but then we are using for the telemetry side Apache Skywalking, as opposed to, for example, something like Prometheus. And Skywalking is excellent for this kind of use case because it is hierarchical out of the box. And so it has this, and so it lets us do the push up to aggregate metrics in the management plane very easily. And we are heavily involved in all of those projects, but no, the product itself is not open source. And this is actually a pretty important key for us because it gets to how we think about the world. And sorry, as Peter's doing things here, let me bring us up to speed. So all that he did there is run a little script that starts to deploy the control plane components into a fresh cluster. And so we can look at that script if we want real quick. It's a little gnarly because there's a bunch of sleeps and stuff in there because really in practice in a customer site, we do this with a CI/CD system, right? We're not going to be running bash scripts to stand up clusters.
You can run bash and CI/CD.
We can. And so instead, what this bash script does is actually shell out to a couple of tools and utilities that we ship as part of TSB for that local installation. And sorry, so let me go back to that point because it's pretty important how we think about the open source world, right? So traditional open core companies, as a developer, when I build a new feature for the thing, I have to decide, do I check in that feature to the product or to the project? And when we set up Tetrate, we wanted to be very clear that we could never have that dichotomy, right? No one at Tetrate should ever be confused. Do I check in project or product? The answer is it goes to the project because in our product, we're not working, we're not adding features and functionality to Istio that are held back from open source. We're instead adding value in terms of management, audit, control, stitching together these disparate pieces. So the more functionality that exists in Istio, the more cool stuff that we can do over in TSB, right? And this is a really important dichotomy for us because it means that we're always incentivized to add stuff to Istio. We're never incentivized to be like, hey, let's hold this back in our version and not. We want it to go to the community. And we think this is a really important, we think it's an important kind of change versus a traditional open core model. For that hopefully helps the health of the projects, right? And we think it's been a good mix. And so here, coming back to the demo, popping the stack a little bit, we're spinning up the cluster. It's still coming, and we do see that it has appeared in the list, although we haven't quite figured out what type of cluster it is just yet, but it is present. And over the next couple of minutes here, it worked perfectly in the demo in our prep dry run right before, which means that now, of course, it's going to take more time.
Everything goes slow when you're watching it. It's cool.
Of course. Is it boiled yet?
Actually, it said it had some issues, so I'm trying.
Oh no!
Yeah,
of course. It wouldn't be a demo.
Exited with an error, so I'm trying to see what exactly.
Oh, fun. Do you mind debugging for us live? Basically, it looks like there's a set of secrets that some of the tooling helps create that's part of what's automated there in that script. And so it looks like we didn't quite create the new secret correctly in the script.
I restarted it, so it seems to be
excellent. And so, yeah, if we look, great. And so one of the other things, we haven't talked a huge amount. I talked a little bit about the TSB architecture. But here we're actually starting to see a little bit more. So we deploy an operator there into the Istio system. We do that because one of the features that TSB does is help manage the Istio lifecycle, right? So of course, as the number of cluster grows, actually managing what Istio versions are out there in the wild and across all of your infrastructure becomes actually a key challenge. And historically, Istio upgrades have been a little painful, although the open source project has really made that substantially better over the last maybe 4 to 5 releases. And so one of the key pain points we've had with customers historically is Istio lifecycle management. And so we do use an operator there to manage Istio in the cluster, as well as our little control plane. Our control plane, at the end of the day, produces Istio CRDs that it sends to the local Kube API server, and Istio just reads those CRDs and does its thing. So one thing I'll note here too is, say if you wind up, trying this out and you don't like Tetrate, don't like TSB, whatever, you can rip it all out, and you're still left at the end of the day with your Istio config pickled there in each of the clusters, kind of running as it was.
A question I had earlier when you mentioned that you're using skywalking with a hierarchical approach for configuration, and even when you mentioned your security config is hierarchical, so I can apply something globally.
Yeah.
Do you run into any conflicts there with Kubernetes by default being label based and composable versus hierarchical? I see like more hierarchy things being pushed into Kubernetes, like namespaces, and even in like other project like Cluster API now has cluster classes, and like that stuff is starting to become like, hey, you know what? Like labels are great for flexibility, but it's hard at scale.
Exactly.
And I'm trying to figure out like where are the pieces that maybe you've seen that were like, oh, this hierarchy thing didn't really work, but I needed a label, or labels didn't work, and hierarchy's better.
Yeah, so I think there's a couple different. So this actually gets a pretty fundamental. So you're scratching an itch here. That's kind of one of my other big areas of research. So I mentioned I work with NIST there. I actually specifically do research on access control. One of the other things that I did in Google before I worked on the service mesh there was actually work on the central resource hierarchy team in GCP. So projects, organizations, folders, as well as the IAM teams. So this is one that's near and dear to my heart. So hierarchy versus labels fundamentally gets at one of the key problems of attribute-based access control. So labels are attributes. The fundamental problem of an attribute-based system is that there's no rules, right? Or rather, there are only as many rules as you and your organization create and enforce, right? In terms of what attributes mean, how they map together, and what that policy does. And so what we see is that it becomes very hard to manage. This is the reaction. As the number of clusters grow, the number of teams on those clusters grow, it becomes an impossible to manage piece. And so we got to reach back for more simple.
Yeah, or as you pointed out earlier, as long as like things are named a certain way, or everyone adheres to like a certain
and that's
guides.
what I mean by rules. That's what I mean by rules, right? And so it has to be enshrined like in your organization. If I go to a new organization, it's like they have different rules. I'm like, oops, crap, it's different, right? And that's exactly the same problem with every ABAC system in the wild when it comes to access control too. It's the same problem. So what do we do when presented with that problem? There's a whole bunch of different potential solutions. But one of the ones that we as industry have decided is a pretty good one is RBAC plus hierarchy. And as an example, every single cloud provider, that is how permissions work, right? So the AWS IAM is fundamentally an RBAC-based system. It's extended. It does ABAC things on roughly your account hierarchy, right? We can have organizational policy. We can have OUs there. We can have the accounts underneath it. We have a little bit of hierarchy there. GCP, the exact same, right? And so for us, we find that this actually maps pretty naturally to how enterprises have thought about the world. And then, your question was, great, so how does this map into the kube space? And so effectively for us, the leaf is a namespace, right? We can go down to individual services there. And so there's a little bit of label matching when you do that. We prefer to go to a namespace level. And we found with most folks that we work with, that's for them the right level of security, right? It's the right mix between keeping a team agile and moving quickly and keeping the stuff secure, right? And so that winds up being a pretty easy mapping for us as we go down the bottom of it. For us is the Kubernetes, our set of Kubernetes namespaces. And for us, that's a workspace. And so that's the bottom.
Yeah. Eric brought in a question too that we might want to talk about. Peter, you're still troubleshooting that one, right?
Yeah, so the problem is when I was cleaning up it before demo, it left some artifacts, so now they conflict.
Oh, of course, I knew that was going to happen. Always.
We got a few more minutes, so go ahead and we can answer Eric's question here too.
Yep. So great. So what about the proxy server, the sidecar model versus a node-based model? So this actually has really, really, really important security implications, right? So I mentioned that we're doing identity in the service mesh. What that really means is that Envoy has a certificate that has an identity inside of it. And when Envoy goes and connects to another system on your behalf, it's going to present that certificate with that identity inside. Now, let's imagine that we have an Envoy per node rather than per service. So hopefully it's pretty clear for everybody. When the Envoy is in the pod with the application, that's very straightforward. There's one application there, there's one Envoy there, there's one identity there, it maps. When we move to a per node model, suddenly we have a variety of different identities that are present on the node, because any pod could get scheduled on the node, right? Setting aside tolerances and taints and all of that stuff, right? In theory, any workload can get scheduled on any node, which means that your one node level Envoy then has to present a variety of different identities, right? And so in modern systems, because I see your question about legacy, I'll get there in a second. So in modern systems, we want to avoid that. And so we strongly recommend an Envoy per application model. So now coming to legacy VMs, this is one of the key things that we try and do, that TSV does, right? So we showed you we actually had some EC2 VMs there that were serving traffic and all here. In that world, it is very common that we're going to have a variety of different applications on that same VM. How does your security policy work today? Chances are that you're, allow listing or deny listing that VM based on IP, right? Based on subnet. And so effectively you're treating that as one identity anyway. And so we recommend as a starting point, have one Envoy on that VM, have it present one identity on behalf of that VM. And then what we recommend for folks is, as you start to want to decompose that VM into services and break it apart and have more granular identities, we recommend putting in more Envoys, one for each. And so yes, there's some overhead there. It keeps it avoids a confused deputy problem. So that's the fundamental thing that we need to avoid with it. So sorry, I didn't lay that out. With a node-based Envoy, the fundamental security problem that you have is a confused deputy, where it is relatively easy for an application to trick Envoy into presenting the wrong credential on behalf of that application, therefore allowing some access that wasn't intended. That's a confused deputy problem. That's why you don't want Envoy holding multiple identities. So for legacy VMs, we recommend starting with one identity, expanding out to have multiple Envoys per VM with an identity per. Yes, you still have a confused deputy problem in that world, but that puts you in the right spot to then be able to peel out that application and Envoy together as a unit to move into a container, for example. And so that's as you're kind of strangling that VM application, right?
And going right back to our security model of how a service mesh works, right? Like if I live in a house with 5 people, I have locks on my doors and alarms on my windows, but everyone inside, we have
code.
free reign to go everywhere. But if in an apartment building, I want a key for every door. Everyone gets their own privacy. They get their own security boundaries of, hey, we share a building, we share some infrastructure, but every unit of dwelling is an individual's place. And that's exactly what we want for sidecar proxies in Envoy that's at a service, at a pod level versus at a node level.
Exactly. That's a beautiful analogy. I love that. That's perfect.
So sorry to interrupt. So finally I cleaned up cluster. You see we're back. So it took 100 seconds for everything to get deployed. Book info.
5 minutes and we count twice.
I believe book info is still deploying. Let me just see. And
we're there. And of course, just real quick, ready 2 out of 2. We have sidecars there deployed, right? So we did go ahead and label the namespace ahead as we stood up that cluster in that script.
So next thing, so it's an alt screen, don't ignore it. So next thing, I need to basically put traffic on this, but you can see here, we already have this site free I just added. So it's in Canada Central Region and it just got added. So discovered all services. And yeah, so last thing, if we have time, I can put traffic on it and we can see it will come up in.
Yeah, let's do the. And so again, we're going to be adding the traffic in the exact same way we've done the other ones. So you've seen already a couple of these, us Tkettle applying the tier 1 gateway config, 4 clusters, I'll give you $5 so you can guess what the config is going to be there, right? We're doing is a 25% traffic split across all 4 clusters.
And as
So
this is coming
I
up,
have here.
oh,
No.
as this is coming up, we do need to wrap up. And so I wanted to, as we're getting this going, is there anywhere that we want, if people want to learn more, that they should go? What are some other, sites or resources?
Yeah, so a couple places. So obviously for all things Istio, istio.io is the way to go. Hit us up on Slack, hit us up on the discuss.istio.io if you're having problems. Definitely come hang out with the community there. Would love to talk with y'all. On the Tetrate side, of course, tetrate.io is our website. Go there, lots of good resources and information about TSV, about Istio as well. And then the final place I want to plug just real quick is academy.tetrate.io, which has a whole bunch of free online training, education on Istio as well that you can go and use. This was some really cool stuff that I was really, really excited for us to be able to put together and release to everybody. And so here in the background, we now have 4 clusters. We can see, our tiny little tier 1 that's off to the top left there. And if you squint really, really hard, you can see 4 green lines coming out of it that are the traffic being distributed across these 4 clusters. And again, sorry, the graph is a little funky in this alpha build that we're demoing here today.
Actually, it's one of UI feature. When you zoom out, you see it turns them to the dots, and you can actually see what color dots are in your large service mesh, because looking at each service in an enterprise environment, that's quite difficult. So
and to be clear, that's why we have the dependency view, right? Because I think maybe most people remember the really, really funny Uber picture of their service graph was a giant circle, right? That's what every service graph is in practice when you get enough microservices. And so this view becomes very clogged, and that's why you have scope down views.
Yeah, this is great. So I want to thank you both for coming and showing off Tetrate. This is really cool, just seeing how multi-cluster and that automatic failover and Istio management can work. So
yeah, nice, awesome, thank you. And on the security side, of course, we had security policies in place. I didn't show them to you, but we had service policies and encryption and transit throughout. But yeah, thank you all for having us. Really, really fun. Had a great time.
Yeah,
if there's any other questions, follow up. There's my Twitter as well, so feel free to DM or tweet me.
Awesome.
Cool.
All right, thanks so much.
Justin.
Thanks everyone coming.
Yeah.
Bye.